Alright, so I'm going to talk through how to do one of these resolving vectors question. What you tend to have is two arrows sort of pointing upwards and sort of sideways, like diagonal, and you're asked to find the resultant force downwards. So you have to do this with a ruler and a protractor, so I can't do it too accurately on here, but I can give you the gist of what you've got to do. First thing you need to do is come up with a scale. Now, I've got 1220 newtons and 950 newtons there. So I'm going to use a scale, I guess 100th, so 1220 newtons becomes 12.2 centimeters. I don't think I have any arrow. Do I have length drawing things? Yeah, I don't have any straight line drawing apparatus on this app, so I'll try and do it as best I can without. But first of all, you're going to draw an arrow that's 12.2 centimeters in that direction. And then you're going to take out your protractor, and you're going to measure out the angle between the two forces, 40 plus 30, which is 70. So I'm going to measure out the angle 70, and then I'm going to do a 9.5 centimeter arrow, hopefully about there. My scale is probably not great, but you know, gives you the idea. Then what you've got to do is make a parallelogram out of this. Let me just label that angle on there, actually. So you've got that. So that angle there, that's your 70 degrees. I do need a stylus. Next then is the parallelogram, so we draw it like this, and like this, and hopefully you can see that's pretty close to a parallelogram. All we do now is find the distance from here up to here. And if we measure that distance, it'll probably come out to, I don't know off the top of my head, and I can't measure it, and I haven't got a calculator, so I can't calculate it. I can't even guess. Let's guess 15 centimeters. I have no idea if that is right. 15 centimeters, and that would be equal to 1500 newtons. So that means that upwards there is a force of 1500 newtons. If we zoom back in on this, upwards there's a force of 1500 newtons. That's the resultant of those two, is 1500. Now if the box is in equilibrium and it isn't falling, that means there must also be a downwards force of 1500 newtons. So that's how we can use the two vectors, the 950 and the 1220, to find the resultant upwards force. And then we can say the resultant upwards force must be equal to the total downwards force unless the box is falling. And we can assume here that it's not. Hopefully that makes sense. Scale drawings are normally like a 5-mark question. You're quite often asked to state your scale and state the direction of the resultant. Now, the resultant force that you've done is upwards, but the weight of the box is downwards. So be careful when answering these questions. Definitely make sure you can do them though, because they are easy marks if you know what you're doing. Oh, and don't forget a protractor for the exam.